Yes, thank you for having invited me to talk on this very important issue, salmonella contamination in feed factories. Prevention, monitoring, and control measures. This is a very big area, and I try to cover it, and I do it in the following way. And the following way, my outline is as follows. First, I go to look at basic facts on salmonella, then the similar thing for the epidemiology, and the real impact of salmonella contaminated feed. And then I come to the control measures and experiences when such measures has been introduced, and then some summary and conclusions. So the basic facts about salmonella is that it doesn't belong to the normal intestinal microflora of animals or humans. And it does not normally occur in the environment. That has often been said that this is the case. But it is a pathogen. Instead, it is a pathogen for both human and animals. And in particular for the animal feed, it can be controlled, but it can never be eradicated. So you have to be alert all the time. And the overriding challenge for why we deal with salmonella is the big burden of foodborne illness. And this is of very great magnitude. So WHO, World Health Organization, has calculated that every year 600 million people get sick of foodborne diseases. Close to 500,000 die. In the United States, we came to the following figure that 1 in 6 Americans can expect to be affected every year. And in the United States, we have 120,000 that require hospital care and 3,000 die. And when you look to the individual agents causing all these diseases, these salmonella are in the top. So the control of salmonella is of utmost importance to decrease the problem with feedborne illness. And our current alert and interest in salmonella, that arise from a pandemic. And it was one of these 2,400 salmonella strains that we have. It changed its properties like a mutation, and it could infect the egg. Before, salmonella chicken egg were safe to eat, but now they could be contaminated by salmonella. And it was a perfect way of spreading the infection. So directly to the consumer when we were eating it, and also directly to the chicken that were hatched from the eggs. And here are the results from one typical country. It's Germany in Europe. And you can see from a steady state, the number of salmonellosis were very low, or rather low, but then there was a steady increase that came further on, and that was due to industrialization of animal production. It was often discussed at that time, but there was no big issues initiative taken to control. But when this pandemic came, everybody understood we have to do something, and only in Germany it was estimated that 2 million people were infected. So there was a global response, and WHO had a consultation in Geneva, and following that, Sweden were asked to give an international course on the control of salmonella in poultry. And I was on this course, and I also became a keynote speaker later on when the World Animal Health Organization highlighted salmonella as the main topic, and before it was usually foot-and-mouth disease and other diseases. So it was a big alert because of this pandemic. And if we then go to the epidemiology, so in older days, you can see this view. It's actually from WHO in the 1980s. And there you can see salmonella. You can find it everywhere in meat, you can find it in water and so on. And for me, this one is an excuse for doing nothing. So this is, for me, a wrong way to look upon the control of salmonella. Instead, you have to base the epidemiology and control on the root of infection and the source of infection. And we start with humans. So salmonella-infected food animals are the primary source of foodborne salmonellosis in humans. The infected animals, we spread it to the neighboring animals and to the environment, and then we spread it to the humans, and the humans spread it also by the manure to the environment. And in humans, it is a per-oral infection that we get after eating contaminated food. In animals, it's a similar thing, and the animals are contaminated by, infected by contaminated feed, and it's also a per-oral infection in humans. You see the chickens eating here. And in feed, it is contaminated by the ingredients, which are the main source for introducing salmonella into the feed meals that I will show later on. So if we look to the impact on contaminated feed, it is often very difficult to describe all this, but this is a perfect example done in the United States. So in 1968, fish meal were contaminated with Salmonella agona in Peru, and it was exported from Peru. And shortly afterwards, this Salmonella agona emerged as a public health problem in several countries. And before, it was very seldom seen in humans or animals. And after a couple of years, it has gone up. So it was on the 10 top list of the most important Salmonella serovars causing human foodborne diseases in United States, in United Kingdom, and other countries as well. And after 20 years, it was estimated that only in the United States, this introduction from the fish meal has caused more than 1 million human sickness only in the United States. And we can consider how large is the global illness until today caused by agona. And when we see infection by agona today, you don't think it's a feed-borne infection because it's prevalent and circulating, but it was introduced as a feed-borne infection. And how about the other Salmonella serovars that are introduced by the feed? And these Salmonellas, they can also spread antimicrobial resistance. So if we then look to the chickens and the impact in chickens, and in the chickens, Salmonella, the major source for Salmonella are the breeding animals and the feed. But the breeding animals, they are also infected by contaminated feed. So due to the special production in poultry, this exemplify the importance of Salmonella-free feed. And if you have infected grandparents' chickens, and 10,000 grandparent chicken, they gave rise to 45 million broiler chickens. So if you get an infection up in the top, it is easily spread to a huge number of animals. And that was the reason why the pandemic spread by the egg-borne Salmonella reached such pandemic proportions. And if we come to the broiler production, it's also very special because the production is very short. After 1 month, they are ready for slaughter. So the message is that feed and breeding animal must be free from Salmonella from the start, because there is no time for action during the breeding period. So when we look to the impact of feed ingredients, the feed were contaminated by feed ingredients. And vegetable, and there are different risks with different feed ingredients. The highest risk are with animal-derived protein, but these are usually forbidden anyway in Europe because the risk of prions causing the mad cow disease. But the one that we use today that are also high-risk material for Salmonella contamination is the vegetable proteins, soybean and rapeseed meal. And here is an example where this is very well studied and exemplified. This is a Norwegian crushing plant, and these are results from 18 years. And this plant import soybeans from South America. And when we unload the soybeans into a into a crushing plant, we take continuously sample. And during all these years, we took around 6,000 samples, and 34% of these were contaminated by Salmonella. In some years, there were over 60% of the samples that were contaminated by Salmonella. And there are numerous data also on rapeseed meal. And these are published data, all of it. And then there is a saying that many of these Salmonellas coming with the feed, they were previously called exotic strain, and it was said that we don't do anything against these Salmonella because they have no importance. And then you know that all serovars of Salmonella are potentially pathogenic to humans, and so that is the wrong way of looking upon it. And if we look to this Norwegian plant again, who during 18 years, they isolated 92 serovars, and 9 of these serovars were on the EU top list on human salmonellosis. So 92 serovars. And in Sweden, we have, during a 2-year study from a crushing plant for rapeseed meal, rapeseed from Wiruep, during 2 years, we had 38 different serovars, and many of these were also on the top list. So in summary, Salmonella serovars contaminating feed, they include those that commonly cause human foodborne infections, so they cannot be neglected. And here are these serovars from Norway, that we isolated 98 serovars. Here is only 12 of these serovars, and you can see how they shift during the years. So there is a continuous influx of Salmonella with these feed ingredients. And how about the control measures that are important here, of course? And there are 3 lines of defense formulated. The first one is the pre-harvest, that control in the food production, in the animal production, including the feed. The next is the harvest way, so that is improved hygiene during slaughter and further processing of meat. And the last one is the post-harvest, that is the final preparation of food, and educating consumers about taking actions. And which are the best? During all these years before the pandemic, all people said, or the majority said, we go to the post-harvest control. We have to fix this in the kitchen. Then we tried to go to the harvest and treat the slaughtered animals with different chemicals, but it didn't work. So you have to go to the pre-harvest control. You have to work along all lines, but you have to go to the top of the pyramid, to the pre-harvest control and the feed. And when we had this crisis in global crisis, when the egg-borne Salmonella, then when we should look upon this problem in EU, the responsible commissioner concluded that animal feed is probably the weakest link in the food chain. So if we then go into the feed mills and see how we will control, so this is a big challenge. They are different size, different age, but we have similar structure. So you can structure a feed mill like this. You have the intake of a feed in one intake of a feed. You have a pneumatic intake, then you have you store the feed, these ingredients in different bags and your elevators, and you move them, and you mill, and you pre-bin with mixtures and vitamins and so on. And then you have conditioner and heat treatment, and then you have a cooler, and then you have a storage bin for the final feed. So you can structure a feed mill like this. And how will you control it? Traditionally, and this has always been, still is the case, that you check, of course, the final feed. And this is a wrong way to do it, just to concentrate on the final feed. Because if you find Salmonella there, it's too late to do correction. If you find Salmonella in the final feed, it is already delivering to the animal farms. And if you find Salmonella, the contamination is usually very high because there are so big volumes, so you need a lot. So if you pick up Salmonella in these samples, you can take if the concentration is high. And if you don't find any Salmonella in this sample of the final feed, it's a very limited guarantee for freedom. So now generally accepted is that you should have a control based on hazard analysis at critical control points, usually called HACCP. And why? Because in all countries, including countries like my own, there is a continuous high risk for introducing Salmonella to feed mills. And the strategy for control is to implement processing conditions aimed at reducing this contamination. And the HACCP control, this object of a HACCP control is to detect this contamination as soon as possible. And the most important, then you can take corrective actions to reduce or eliminate this contamination. And Sweden learned this in a very clear way. So we have controlled Salmonella for 70 years ago. And the lesson we learned that illustrate this situation is the following. We, during one period in one area of the country, had 15 chicken producers, broiler producers, and they were all repeatedly infected by one Salmonella strain, Salmonella Livingston. And they got feed from one feed factory. And there was a big alert in the feed factory, and they checked the final feed primarily, but they never find any Salmonella. We'd find the Salmonella Livingston when we went into the feed factory, into the tubes. And what happened during this period? So during 7 months period, chickens were repeatedly infected from the feed mill, in spite they have been intensively looked into the final feed for Salmonella. So the concentration was so low we couldn't pick it up, but the chickens were infected. So the conclusion is that we have to introduce HACCP system. And if you go into the HACCP system, you should have critical control points. And here are exemplified the most critical control points. That is pooled sample of dust from the top of the finished feed. So you don't test the finished feed, but you test the dust from the finished feed. And you test from the cooling rooms and from the coolers and from the central aspiration from the whole mill and also from the intake pit. And the major focus is to detect recontamination after the heat treatment that should be in place. So in both crushing plants and in feed mills, if you have heat treatment that you should have, then you kill all the Salmonella. So if you just can avoid recontamination after heat treatment, you have solved the problem. So this is very important to highlight. So here about the sampling procedures in the HACCP system. You do regular sampling usually every week, and you plan the sampling like this here, and then you have referral to the laboratory, and then you go and pick up your equipment for the sampling. And these are very simple equipment. They are like this. You have cotton swabs, sterile cotton swabs, and you have moisture, sterile water, or slightly saline water. And then you have the plastic bag to ship the sample. And here are the sampling from the finished feed. There are 2 examples. So instead of taking the finished feed from the feed itself, you go to the top of the bins where the finished feed are stored. So there is dust from the finished feed, and experience has shown that this is the best way of isolating Salmonella. So here are the top of this feed mill, and you open up this lid and you take this sample as you see on the slide here. And here is another meal where it's look like this, and these are the top of the feed, finished feed are underneath, and you open up here and you take the samples there. And here is from the pellet cooler and dust cooler room. So there in the tube, there should always be opening so you can go in, and then you take the scraping there, and here you also take from the dust from the room, and here to the right, down to the right, you can see how we have taken sample within the cooler, and the dark blue area is where we have swiped over. So you have to swipe over a certain area. And when you do this, you change your sterile new cloths between each sampling, not to avoid cross-contamination. And here is an example from Sweden when we introduced the feed mill control, and how we control Salmonella in poultry production in feed mills. First, we have grade classified the ingredients according to risk. So high-risk feed ingredients, this is like soybean meal and rapeseed meal. Before we are allowed to go into the feed mill, they have to be tested. So in each batch, we test about 40 samples per batch. And if they are contaminated, we are decontaminated, usually by a mixture with organic acid. And then you test them again, and they are not allowed to come into before we are negative. They are not free of Salmonella, but then you reduce the risk. And in the feed factory, we have these control points. It is the same as you saw on the previous slide. And we take this sample every year, and this is around 260 samples a year. And heat treatment is mandatory for chicken feed or poultry feed. And then we do additional sampling. So when you find Salmonella in all these samples before, then you go back and see how spread it is. So then you take 40 samples to check it up, and then you decontaminate, try to eliminate or reduce, and then you check again, and the whole plant is checked once a year. And this sampling and this control, of course, costs money, but it is a very limited cost. And the industry, who has no interest in downgrade this control, they have calculated all the costs involved, and actually also odd occasion where we have closed feed mills because they needed to clean it up. And the price for all these were less than 1% of a customer's feed price. So when you split this cost on the big volumes of feed, it is very low. So here are experience from introduction of these control strategies. So here is a summary in Sweden of all the feed factories when we introduced HACCP control. And if you see these red staples, they have a number of samples that are taken in all these feed mills. And you see a dotted small line here. That is the number of contaminations of those who were Salmonella contaminated. And the contamination decreased despite increased sampling. And the experience is that you often can hear feed mills to say, we have no Salmonella, we find no Salmonella. And then you have reason to mistrust because you find Salmonella in all feed mills. But the challenge is to have it at a low level so the feed is free. And this is very well illustrated again in this Norwegian plant, crushing plant. So you can see they had 34% of the sample during 19 years from the soybean were contaminated. And here is a sample from 1 year. Sorry for my coughing. And here are the number of samples taken. They take 4,000 samples a year. And in this year, 12% of a sample of a feed meal of a soybean were contaminated. In the outdoor environment, 20% were contaminated. Sorry about this. And the indoor environment in the unclean area, 9% were contaminated. And in the clean area after heat treatment, a few cases were contaminated, but the final feed was free. And you can see the number of samples taken. They were mostly taken, so more than 60% were taken in the final. So the plant was heavily contaminated in the environment, but they could make the feed free anyway. Sorry about this. So it is shown that it's possible to produce salmonella-free feed under industrial scale. You have this crushing plant that I showed here, that in Norway and Sweden, and there are probably more, but we don't have data from them. And then you also have poultry meat feed that is free. And this is the best way of demonstrating this, is that when you test the chickens before slaughter, like in this country, and they have been going on for years, so it is possible. Of course, there are breakdowns, but then you clean it up. And if I take Sweden as an example, because we started to control salmonella 70 years ago, and we are like other countries, the risks are similar here. And our control started with a big crisis that for many decades was the biggest salmonella outbreak in the world. So we had 9,000 people sick and 90 people died, and it was spread from a slaughterhouse. So then we control all serovaurs of salmonella, and we have a non-acceptance policy for any serovar in feed, in animals, and in food. And the result is, in many decades, that we have a salmonella-free animal and feed production. And actually this pandemic, as I demonstrated before, that is, we alert why everybody deals with salmonella today, is that never entered Sweden because our rather simple control were in place. So we could stop it at the borders. We never got this into our animal production. So in the summary from the EU, they took actions. So at the beginning, they had 200,000 human cases per year. And after 10 years, they had decreased bees by 50%. In spite, they have enlarged the EU by 10 more countries. But these are published, but I might say that this decrease was mainly because we took action in the poultry production. So they haven't done, we have big efforts for the feed, but we haven't implemented them, so there are much more to do. And there are changes underway for the control of salmonella in feed. And today, I dare to say that the industry start to show responsibility. And they, in the Europe, we even developed guidelines for the control. And earlier, actually, the feed industry, these big companies, they more or less denied the existence of salmonella, and it wasn't mentioned on their web page or anything. But there is a change going on. And farmers, they understand, because we push the farmers to have salmonella-free animals, or so you don't contaminate it from them. And the farmers understand there is no reason for us to control salmonella and take big action on our farms if we are contaminated by the feed and the breeding animals. And the breeding animals also get contaminated by the feed. So you have to go there. And in another article, another indication that I think very personal, I wrote a big scientific article about the importance of salmonella-free food, salmonella-free feed. And when you write this article, you often think that there are very few who read them because it's a very narrow area. But when I looked on the website some months ago, this has been downloaded 1,500 times. So this is a substantial interest in the area. So now I come to my summary, and the summary is as follows: that feed is the major source for introduction of Salmonella to the animal production, with the subsequent risk of spread to food chain and the environment. And it is also shown possible to produce salmonella-free feed under industrial scale for when it's established for less than 1% of the feed price. And this is a price that is found worth the cost for feed quality, consumer safety, and prevention of new crises that may come. And Salmonella, and this I think is an important message, the Salmonella-safe feed require the active and responsible engagement by feed industry. And testing is required to verify that the control programs are working, and intervention has to be done when you detect Salmonella. So that is important. You cannot control Salmonella only by sampling. So that was the end of my presentation. So thanks a lot for your attention, and sorry for coughing here. Thanks a lot. Bye.